My name is Deval Parikh. I'm a senior solutions architect at AWS. Today we're talking about AWS Well-Architected Best Practices for DevOps. And joining me is...
Yeah, Ilamaran. I go by Ila. I'm a senior container specialist solutions architect with AWS, and I'm also a DevOps and observability evangelist. All right. Am I too loud or am I good? Okay. So we have a jam-packed agenda for this session. We're going to start with talking about modern DevOps, and then we're going to talk about AWS Well-Architected Framework. And then we'll start with a sample pipeline architecture with no bells and whistles. And then we will dive into best practices across 5 different genres, which is organization adoption. Then we'll talk about quality assurance, development lifecycle, governance, and then finally we'll end with observability. And then we'll talk about the final DevOps architecture with all the bells and whistles and all the best practices that we have implemented with the sample architecture. And then we'll conclude with the closing remarks. All right. So as always, we would like to start with a quote. This is a quote from one of the famous founders of IT Revolution and a DevOps guru. So what he says is, DevOps is obviously a collection of practices. It's basically descriptive and prescriptive practices, and it's also a philosophical movement. So it's basically an organizational philosophical movement. So I would highly recommend to read about Jim Kim. He's a great author, researcher. He has written so much books. All right. Okay, Deval, what is modern DevOps?
Yeah.
Talk about it, please.
Great question. But before I get there, I want to get a pulse in this room, and quick question. How many of you guys are managers, directors, executives in this room? Wow, quite a few hands. And developers, system administrators?
Yeah, I see a lot.
Cool. I love my developers. I'm from a development background. So let's talk a little bit about what good looks like, right? Gone are the days when you had to go to IT to procure a server, resources, build up your runtime, install your operating system, your tooling, just so that your team can start developing in them. It was cumbersome. And again, I come from a development background, started my journey in 2004, and back in those days, I was working as a developer at the Boeing company. There used to be a dev team, and there used to be an ops team, right? We did not interact much. They didn't like us. I'd write code, and they'd figure out how to run it. It was almost as if there was a clear wall between the two teams. I'd throw the code over the wall, and if it works, they would keep it. If it did not, they'd throw it back to me for rework. Non-functional testing like security testing or performance testing was done only once when the application or the product was newly built. After that, God knows. And there was inconsistent tooling across the board to develop, test, and deploy code into production. A lot of challenges at the time, but we've moved quite a bit away from that type of organizational structures and processes and whatnot. So today, as you guys all know, startups are taking on big giants, and that's primarily because they are able to adapt quickly to modern DevOps practices. DevOps teams today are using automation to build and provision infrastructure in a matter of minutes rather than days. They're employing CI/CD best practices, right? CI/CD pipelines to continuously build, test, release code with fewer rollbacks. Very important, fewer rollbacks. Non-functional requirements like security, performance testing are built into these pipelines so that they can run with every new iteration or change to the application. And then what it does is it, in turn, enables organizations to standardize on tooling, best practices, make them repeatable processes across the organization. So huge change in the philosophy and where we've come to. So I want to just simplify what I said into 4 best practices as it relates to DevOps. First, accountability. Remove those silos, right? we're now bringing the development and the operations team together. We call these teams as 2 pizza teams. We don't have teams bigger than 12 people at a time. They're accountable for everything and anything related to a product, a feature, a service, whatever it may be. Automation to speed up delivery and reduce human interaction and errors, right? Key to moving faster, get the features out there, compete. Awareness of your entire ecosystem with so much tooling employed, observability becomes very, very important within an organization. And so it's important that you understand that DevOps is not just code, build, release, but it's also making sure that that entire end-to-end process is observed all the way until the application is in production and obviously beyond that. And Eli is going to talk about that in a short while. And then the fourth one that's important is autonomy via centrally enforced standards and governance. We all have policies within organizations that we have to abide by. Sometimes it could be also government requirements, who knows. So if you're doing any kind of DevOps, this is how a typical pipeline may look like for you guys. Can I see some nods? Yes, no? And my apologies, the lights are coming in my way, but maybe a thumbs up. DevOps? Folks doing DevOps? Cool. On the left, you have your developers checking code into a code repository. Perhaps you're using GitHub in the cloud or a similar service. The pipeline that picks up your code and builds it with dependencies, runtime, and configuration. The build creates an image. It is checked into an image repository. I'm just showing an Amazon ECR, which is an Elastic Container Repository. It was similar to that. You could have a Nexus repository, who knows. And once this is ready to be deployed, you may either have a manual process today within your organization, or you may be using tooling, maybe Spinnaker, or maybe something like AWS Code Deploy to actually deploy the application into your pre-production and production environments. What we want to do in this session is actually introduce best practices at each step of this DevOps pipeline and align them to an AWS Well-Architected Framework. So anybody knows what a AWS Well-Architected Framework is? Have they heard about them? A couple hands, but let's have Eli explain this even better in the next few slides. Eli.
All right, I see a good number of hands raised. That's awesome to hear, but let's zoom in a little bit about what is a well-architected framework. Okay. Before that, a question. How many of you have seen buildings which is structurally damaged? Anyone? Awesome. What could be the reason? The fundamental reason you might see is the foundations are not solid, right? If the foundation is not solid, the building is going to have structural damage. It's going to eventually collapse at some point of time. So that is where well-architected framework comes into picture. It's going to help you build your solutions in AWS so that your solutions does not collapse in AWS, meaning it is well-architected. So we start with the pillars. The pillars are the foundations, which is going to help you have a good, solid environment or your solution running in AWS. So we'll zoom in a little bit on pillars, all the 6 pillars of well-architected framework in the next slide, but the pillars are the foundations of well-architected framework. And then with pillars, the next important thing is design principles. So what is design principles? Design principles are best practices that we have accumulated, learning, working with so many different customers over the past few years, and arriving at a set of principles that we can apply onto your solutions and that you deploy on AWS. The next important thing is questions. So how we approach well-architected framework is we use a set of questionnaires. We're going to ask you questions around how is your performance, how is your CPU utilization, are you having a right DevOps, are you going to have a DevSecOps process. So we're going to frame a questionnaire kind of an approach in well-architected framework package, and that is how we're going to help you align to your solutions that is well-architected in AWS. So these are 3 important things which dictates what is well-architected framework, but the most fundamental thing that we have to learn what is a well-architected framework is pillars. So let's zoom in a little bit on what those are. To start with, the first pillar is operational excellence. So the operational excellence pillars, it's going to fundamentally focus on how your systems have that ability to run and monitor, how your systems can be monitored and observed, right? So that is what is the fundamental of operational excellence. And then the next important thing is security pillar. Security pillar is going to focus on whether your assets are protected, it's not compromised, there is no leakage of security, and so on and so forth. So security pillar is another important pillar which is very important as part of your application that is running in AWS. And the next important thing is reliability. So you might have seen our Werner Vogel's CTO's code that everything fails all the time. Why does it fail all the time? It's just because it is not reliable. So the reliability pillar is fundamentally going to focus on helping your applications so that it is designed for failure, meaning even if it is going to fail, it's going to withstand failures. So the third pillar is reliability. And the fourth is going to be performance efficiency. So performance efficiency is basically using the right compute resources to satisfy your system needs so that it performs at the right benchmark that is required for your users' best experience. So performance efficiency pillar is another important pillar that focuses on that. And this is a very important one and my favorite one, right? So everybody comes to AWS, it's just for cost. You want to save cost, you want to move from CapEx to OpEx, you want to architect it right so that your solutions are not bleeding cost. So cost optimization pillar is going to focus on that, and it's going to help you not bleed cost and architect your solutions with running in less cost. And the next one is sustainability pillar. So this is a very recently inducted pillar into the Well-Architected Framework. This is basically focusing on lesser carbon footprint, right? So having ecosystem of challenges around carbon footprint and how much carbon is going to go into the ecosystem of our environment. So this pillar is going to focus on that and reducing your carbon footprint as you run your solutions in AWS. So are you there so far? Awesome. All right. So we saw about well-architected framework. Let's dive into the most important thing of this conversation after well-architected framework, which is best practices across the 5 different genres that we talked about. To start with, organization adoption. So from a modern DevOps standpoint, before the tooling, before the talking about governance, observability, organization's adoption into DevOps is the most important thing, right? From an organization standpoint, the adoption and what are the different things that you get by running your modern DevOps with AWS tooling, understanding of that is very important. So that is what this section is going to focus on. So the first fundamental question you might be getting is why you want to use AWS tools for modern DevOps. And these are 6 reasons why you want to run your modern DevOps in AWS. And these are the tools these are the reasons why the tooling that you're going to get for modern DevOps in AWS. To start with, I'm going to focus on each of these items in upcoming slides, but to zoom in around, right, you can build end-to-end solutions with AWS. You don't need to go outside of AWS to build your solutions in AWS, and that's fundamental. And then obviously security. Security is top priority, and we'll talk about why security is top priority and what AWS is going to help us from a security angle, for an organization adoption standpoint. And then we'll talk about moving from CapEx to OpEx, how you can reduce your total cost of ownership, and the reasons why you wanted to use modern DevOps tools with AWS tooling. And then this is another question that I constantly get from customers. Hey, I don't have any AI expertise in my organization. I don't have any ML expertise in my organization. What do I do? How can I use those still for my business improvements, right? That is where we have ecosystem of tools which myself and Deval will be covering out in the next session, meaning the next topic. But the fundamental understanding is that you don't need to have AI or ML expertise to use those for your business improvements. So we'll cover that in more details in the upcoming slide. And then modern DevOps, which needs AWS tooling, which is fundamentally built for developers and organization. You can let your developers do what they want, but you can still from an organization standpoint have the governance and the important controls in place using the AWS tools that we have for your modern DevOps transformation. And then last but not the least, this is another common question I constantly get from customers, right? Hey, I'm a Terraform shop. I use GitHub and I use Pulumi, right? So what do? How can I architect my solutions in AWS? So AWS is very vendor neutral and we support all the ecosystem of non-AWS tooling to architect and run your solutions in AWS. And we'll also talk about that. All right. So this is the ecosystem of tooling that we have in AWS from a modern DevOps standpoint. Starting from authoring, how you can write your code, what are the different tool set that you can write your code, and then sourcing your code, like sourcing your container images in Amazon ECR, or sourcing your code repo in code commit, or code artifact, so on and so forth, right? You have all the ecosystem of tools that you need to source an artifact in AWS. And like building your code or deploying your code, building pipelines, all of those can be achievable using AWS native toolings that we have. And then fundamentally monitoring, seeing how your code is performing using open source tooling or using AWS native tooling. All of those things are achievable through AWS suite of tools end to end. And last but not the least is the model, right? Let's say you want to use CloudFormation, or your developers, you have a lot of Java developers or Python developers. You can still leverages those developer resources and continue to build cloud infrastructure using CDK, something like CDK. So we'll zoom in all of these in upcoming topics, but the fundamental thing here is from an organization adoption standpoint, you can achieve end-to-end, you can build your end-to-end solution in AWS using this suite of products. All right, let's talk about a very important topic, security. Security is obviously top priority. We call it job zero. So from a security standpoint, the first thing is let's take a quick example, right? You might have used Jenkins as a build server. You might have given privileges and access to your developer teams to use the Jenkins server to deploy their pipelines or run their pipelines. How many of you have seen a situation where a developer triggering a prod pipeline? Anyone? Awesome. Yeah. So in AWS, you can fundamentally avoid that. We follow the principle of least privilege. We follow the concept of IAM roles. So you can give right privileges to right folks in your organization so that there is none of these things happen in AWS. So we have the principle of least privilege to restrict access and give right people the right access that is required. And then talking about storing your data. So we have ecosystem of tools to encrypt your data in rest, encrypt your data in transit, which fundamentally means that your data is safe in AWS. So from a security standpoint, data is gold. So from a security standpoint, safeguarding your data is very important, which is something you can achieve in AWS using all the tools that we have from a modern DevOps transformation standpoint. And then talking about your source code, talking about your container images, talking about your repos. So you can employ toolings like Amazon ECR, which comes with scanning of your container images, and using code artifact, which can store your binaries, and so on and so forth. So basically from a code standpoint and scanning standpoint, you have ecosystem of tools in AWS for all the source code and all the artifacts that you house in AWS. And then the next important thing is the networking, right? The traffic, right? Let's say your application, which is an internal facing web application or an external facing web application, depending upon the application needs, you can use concepts like private VPCs and keep your traffic private so that the security of the application or the environment is not compromised. And then, last but not the least is patching. How many of you have seen situations where a server is not patched right in on-prem and that has caused security vulnerabilities to, oh, you see a hand there? Yeah. So it's a traditional problem, right? We see this all the time. So in AWS, when you're running your servers, we take care of patching, which means that you don't need to worry about patching and just focus on your business needs. So from a security standpoint, we have ecosystem of tools and ecosystem of products that is going to really help you to modernize your DevOps and secure your environment and run at scale. All right? Okay, let's talk about this. This is one of my favorite things that I always talk. So your organization is not going to have AI. You're a startup, maybe not have an ML expertise. So what do? How can I leverage AWS, still use AI ML techniques and improve my business? So yes, AWS does provide you ecosystem of tools to achieve that, starting from Code Guru, DevOps Guru. We'll talk about that. But what I'm trying to say here is, from an organization adoption standpoint, you can do a lot of things with AI and ML insights without knowing what is AI and ML. Example is, let's say you have an expensive lines of code, which is basically looping around. You can use our AI and ML tools like DevOps Guru and Code Guru to find those expensive lines of code. And then obviously, there are tools to improve your code quality. So, which are all ML powered tools, but still your organization is still not having AI and ML expertise. So that's a huge win for organizations. So that's with respect to this. And then let's talk about for your developers and for your organization. Typically in any organization, developers want to do whatever they want, which means they want to use their favorite language, they want to use all their favorite tools, and they want to use all their favorite frameworks and still achieve their business goal that is allotted to them. And from an organization standpoint, you want to have safeguarded rules. You don't want your developers to do whatever they want, right? You still wanted to restrict few things, but still give them the flexibility and flexibility to choose the languages they need and choose the tools they need to build their solutions in AWS. So that is something you can achieve at scale in AWS. Even if it's a multi-account scenario, you're using hundreds or thousands of accounts, you can use landing zones, you can use configs, you can use security hub, you can use all those wonderful tools to safeguard your environment, but still allow the developers to do what they want. So that's a huge advantage for organizations for modern DevOps on AWS tool, with AWS tools. And then another important one, and my favorite one too, cost. I have recently had a lot of cost conversations because of the current economic situation, right? So the fundamental reason why you come to AWS is you want to move from CapEx to OpEx. You want to move from a capital expenditure model to an operational expenditure model. So you want to reduce your total cost of ownership. So how can you do that, right? So one way to do that is using the AWS tool suites that we have, which is basically fully managed. Talking about code pipeline, talking about code deploy. So all of these tools are pay-as-you-go model, right? Which means that you don't need to pay for you don't need to worry about the underlying infrastructure, and also you don't need to worry about paying for the full server cost. You just pay as you go, like how you use your electricity and just pay the electric bill, right, for your usage. Likewise, you're going to use the tools and you pay as you go. And also moving to fully managed tools like Amazon Managed Prometheus. Just for example, if you're a Prometheus user, you're going to manage the Prometheus server, you're going to keep it up and running so that it can monitor your applications, right? But with fully managed aspects like Amazon Managed Prometheus, for example, or an Amazon Managed Grafana, so all of these services are fully managed, which means that we take care of the underlying infrastructure, we take care of patching it, we take care of managing it. So all you need to worry about is scale it up, spin it up, and just use it and forget about the underlying infrastructure. So fundamentally, you're reducing your total cost of ownership, and you're moving from CapEx to OpEx models with this all the tools that we have from a modern DevOps standpoint. All right. So last but not the least, for an organization adoption standpoint, is the questions that I get from the customers. I use Terraform, I don't use CloudFormation, I don't have the expertise to use CloudFormation. What do I do? So as I said, right, we integrate with all the non-AWS tooling, most of the non-AWS tooling. We support all the partner tooling. So which means that you can use Terraform, but still achieve modern DevOps. You can spin up a code pipeline, you can spin up a code build, all using Terraform. Likewise, you can use GitHub, you can use Bitbucket, you don't need to use code commit, but still continue to use that and still build your solutions in AWS with all the modern tools that we have. So to sum it up, right, from an organization standpoint, you can achieve end-to-end solutions in AWS, you can achieve develop your solutions at scale, with security, you can use all the non-AWS tooling, reduce your cost, so which means fundamentally you are well architected in AWS just by adopting AWS to run and scale your applications using all the modern DevOps tooling. So with that said, right, we want to move to the next section of this best practices. I'm going to hand it over to Deval. Over to you.
Thanks, Ila. So Ila just kind of went through a very high-level overview of everything DevOps, right? Quite a few words here, and I just want to kind of advise you guys. There's going to be quite a whirlwind of technologies that we're going to be discussing. I'm going to be throwing at you. But what I want to do is, through next set of slides, just dive into each of these sections in more details. So we're going to start with our development lifecycle best practices. I'm just going to try and get another pulse here in the room and try and figure out how many of you guys are actually still, so I know that there's DevOps going on here in this room within your organizations, but do you guys deploy monolith applications using DevOps pipelines? Anybody? Yeah, okay. Anybody else? Oh, there, gentlemen, and there. Okay, yeah, right? So, and that's typical, especially when you are in an enterprise organization, large organizations. Not everything is microservices, or not everything is modern applications. But so, believe it or not, just like you raise your hands, a lot of organizations and customers that I talk to, they claim to run DevOps, but are still running pipelines to build, test, and deploy legacy monolith architectures. Maybe it's a 3-tier application, but it's all bundled up in this one giant file, right? What does that do? It possibly helps you automate some of the processes, remove the silos if we talked about the walls between the developers and the operations folks. But what it doesn't do is help you mitigate some of the pitfalls, right? If that happens, this means that any small change to a module in any of these applications, legacy monolith applications, has the potential to bring down the whole application. You're doing DevOps, but you're not quite doing it right, in my mind. So how do we solve this problem? And you guys possibly have heard about this, right? Operational best practices is to break down monolithic architectures into microservices so that each service in an application runs as an atomic unit. Now, I specialize in modern applications from an architecture standpoint, and I just had a session at DockerCon this year. I was speaking there and helping customers understand there's patterns that you can use, like Strangler pattern, to convert a monolith into microservices. You don't have to do a big bang implementation. You can have both your microservices, refactored code, and your monolith running at the same time. And how do you create that architecture where you're slowly carving your monolith into microservices? But that's a different topic altogether. And what it does is, again, a change in one microservice does not bring down another service because it's running independently of the other. On top of that, I'll kind of go through a few slides where we'll talk about deployment strategies, right? You deploy to an environment, the change doesn't work, even if it is a microservice. How do you make everything highly available is the goal at the same time. So let's talk a little bit about continuous integration, continuous deployment best practices as it relates to application development lifecycle. Some of these things you might have already heard. Your developers are doing it, you guys are doing it. But in terms of continuous integration, this happens mainly during your development and your test phases, right? You work on smallest change possible, or your developers do. Commit early, commit fast, often merge into releases, merge all changes into a release branch, not into your dev branch, and take dev branch and move it into QA or whatever. And obviously, we all know that a developer who merges code early and often will likely have fewer integration issues down the road. You're also going to have to talk about creating unit tests that possibly will provide you with 100% code coverage, at least aim for that. And you want to ensure these tests are kept up to date, right? Unit test failures, in my mind, should not be neglected. Should not be bypassed. They must always be fixed. They must always be kept up to date. Code coverage is a real thing. It's a metric in DevOps, and you must implement that as part of your best practices. What else? Best practice recommendation is to adopt tooling like Maven or Gradle when you're building images during your development and test phases. Across your organization to standardize those tool sets, create automations around this. When we talk about continuous delivery, not a lot of organizations that I know of are still implementing it, but again, maybe a pulse check here will help me understand. Does anyone use tooling for continuous deployment? Production? Hands up. Production environments. Great. Wow.
Great.
That's amazing. What do you guys use? Spinnaker? What do you guys use, guys? Sorry, say it again.
Bamboo.
Cool. Very nice. Yes. Oh, there you go. So again, this happens during your QA or your pre-production environments and production stages, environment stages. So what is important at this point in time is to start introducing your functional and your non-functional testing, mostly your performance, your load testing. Have a best practices where you are doing pessimistic or negative testing. You want to find any reason to fail a deployment, so you're not really putting it out there for your customers. Only promote on success. These are some of the things that you can also automate as you're building your pipelines and your continuous delivery pipelines as well. What else? Test rollback mechanisms. Do beta testing. Get a small group of users to come in and test it out before you actually move it into production. And this is again, a deployment strategy that we'll talk about. All right, let's move on. So just as I said, let's talk about AWS best practices around deployment strategies. This addresses your resiliency pillar. You want to keep things alive, and you want to keep serving your customers no matter what. But before we talk about it, let me give you a small primer. If you've not heard about code deployment, it's a deployment service that automates application deployments to Amazon EC2 instances. It could also deploy to your on-prem instances, to serverless Lambda functions. If you have any of those API Lambda functions that you've built on AWS, container orchestrators like AWS ECS, which is Elastic Container Service, even EKS. The service scales with your infrastructure, and then you can easily deploy to not just one, but thousands of instances as you need it. So co-deploy is pretty powerful. You can see that it integrates really well with AWS ECS, which is the Elastic Container Service, but we can talk about it at a later time. So let's talk about blue-green deployment, what that means. It's a deployment strategy in which you create two identical environments. One of your environment is a blue environment, the other one is green. Blue is running your current application in production. Green is running this new change that is being introduced into the application. And the idea is to really shift traffic between these two environments such that once the green environment is ready and tested, production traffic, my apologies, there's quite a bit of noise here, but production traffic is redirected from blue to green. If any problems arise after you've deployed and things don't work out, roll back to your blue environment. Release your green environments. If you need to rebuild it. But at least you have an active kind of configuration here to ensure that application is available at all times, irrespective of changes being introduced at all times as well. Let's talk about a kind of a twist to the blue-green strategy. We call it canary deployments. Canary deployments are, again, co-deploy has capabilities for you to create canary-style deployments on ECS, some of the other container orchestrators. But basically, it allows you to expose tiny traffic to the new environment. And then gradually, you're increasing in steps to switch over completely. So you're not really just doing that blue to green 100% switch, but you're slowly figuring things out. And there's additional strategies that you can employ. You can use Route 53 DNS or your own DNS to switch traffic gradually. You could also use load balancer strategy. And in AWS, we can use ELB, which is your Elastic Load Balancer, to target groups to do that gradual shift. But great ways to make sure resiliency is met as you move into DevOps automation and DevOps best practices. So if what I've said so far makes any sense, and you think DevOps enables companies to deliver products and features at a high velocity, I'll tell you, that DevSecOps takes it a step further, right? DevSecOps, pretty simple. A lot of you guys may have already heard it. Sec is the security part of your DevOps, making sure that security is integrated into your pipelines as you develop and release code into production. What good is it if you have great DevOps pipeline, great automation, releasing features at the velocity that your organization mandates to be competitive in the market, but has security threats and vulnerabilities in them? It's no good. I mean, what are you guys doing? Just making stuff and pushing it out, but not thinking about it? So having a complete DevSecOps pipeline is critical to building a successful software factory, which does not only include CI and CD, but Ella is going to talk about governance, right? Continuous auditing and governance incorporated into your pipelines. Continuous logging and monitoring incorporated into your pipelines. That's where you want to take your DevOps architectures to. So I'm going to just start looking at, going through this picture here, and my apologies, it looks like this big tunnel that's empty, but there's quite a few things going on here. But let's see how we can integrate security best practices in each step of a CI/CD pipeline. So the first thing is obviously code repository. You don't want developers to be putting in secrets or passwords into your code files. Make sure that's not happening. It's not today's world. If it's happening, create some mechanisms out of it. And that's called secret scanning. Any kind of repository that you have should not have your secrets or passwords in your code files. So you can possibly create a Lambda function that goes and actually checks your lines of codes in the file and figures out a pattern that matches secret formats, and kind of just raise those as security issues down the line, right? Second, when you're building and containerizing your images, so there's a couple things you're doing, right? Does anyone do static analysis in production environment? Sorry, in your development environments. Static analysis, right? So if anybody doesn't understand what a static analysis is, pretty simple. You've got code styles, you've got programming errors. You want to catch them right at the development stage, not let it even get into the testing part. Any kind of suspicious constructs, any kind of infinite loops, possibly stylistic errors, things of that nature are all static analysis. So make sure you're employing those. I'm not going to talk a lot about SBOM and IAC linting, but IAC is basically if you're running infrastructure as a code pipelines, you want to lint those as well. SBOM is your software bill of materials, counting the inventory while you're building your packages. But those are additional ideas. Sorry. Let me see if I can just go back a little bit here. And then Ela talked about Amazon Code Guru. I will talk about it. I'm not going to sit on it, but Amazon Code Guru is kind of a static analysis tool that AWS has, powered by machine learning. So look into that. And then if there's any unqualified images because you found any kind of dependency vulnerabilities while you're doing your static analysis testing, then throw them into a repository and an image repository that calls it unqualified. Okay? And then once you are ready to deploy to test or any higher environments, then you start talking about, hey, by the way, I've built an image and I've checked into a repository, but I need to actually scan it against the CVE databases. Does anyone know CVEs? CVE vulnerabilities, right? These are publicly known vulnerabilities. There's a database. You can kind of just run some of these tools to go and say, hey, do I have these in my dependencies or third-party dependencies? And then dynamic analysis. So once you have deployed it to a test environment, make sure there is additional dynamic analysis for security that is happening down the line. And then make sure you've got some notifications going out from your pipeline. Hey, it's not working. SNS, use SNS for sending out those notifications and downstream, whatever you need to do to mitigate those risks. And as you test and promote this to create a golden copy of your image and say, hey, this is good, this is great, let's move it into production. You want to check it into a possible repository or a set of repository that says promoted images. Have an approval process in place, right? That approval doesn't have to be manual. It could possibly be manual, but the approval process can also be automated. It can be against your code coverage metrics. SAST and DAST metrics, hey, this looks like I'm 80% out of the gate for static analysis and maybe 85% for dynamic analysis. And that, for me, is good. That's a gate. It's an approval gate. It could be an automated check, or it could be a manual check through a Jira system or a ServiceNow system, ticketing system, and somebody goes and says, yep, this looks good. And then that's when you basically are now deploying to production. But once you're in production, you also want to make sure that that golden copy is rescanned for DAST, and image signatures are added to it. So a lot of terms that I threw in, but hopefully this can help you understand that there is a need for security to be an integral part of your DevOps pipelines in terms of best practices, okay? And then we have this security notification aggregator called AWS Security Hub. All of these notifications or any kind of threats that you may detect in the way can be sent to Security Hub. It's kind of like this big dashboard. You could have executives or higher-level managers, directors look at it from an organization perspective and say, hey, how many vulnerabilities am I adding to my systems per day, per whatever, right, per week. Okay. All right, moving on. Let's talk a little bit about quality assurance. Is everybody still okay, alive, alert? It's a lot of theoretical stuff, but hopefully I'm keeping it a little entertaining here. Okay. So now we come back to QA, right? So we talked about security, and great, you guys went out and built this whole thing, SAST, DST, SBOM, IAC linting, image scanning. You got the whole 9 yards built into your pipelines, and you feel great about it. But if you don't meet your functional requirements, you're no good again. You're back to square one. So don't forget you have to integrate those functional testing into your pipelines, right? And so I'm going to just introduce two services that are out there. These are machine learning capability-based services. Amazon, DevOps Guru, Code Guru. Ela talked about it a little bit. But the idea is to integrate them as part of your pipelines, not worry about finding tools or 10 different tools to go out and do this one thing that Amazon DevOps Guru does or Code Guru does. Code Guru, again, is that static analysis part of your pipeline where it goes and you don't have to run your code. It just goes and figures out certain things that your code must adhere to, including styles, and that it will automatically detect those issues. But DevOps Guru is on the operational side, so once it starts running into your test, your higher environments, into your production environments, that's when you will actually use DevOps Guru to additionally detect operational issues. Okay. So let's talk about, again, I'm just kind of going back and forth between these slides. Could have done it better, but here we are. So continuous code improvement. Code Guru is, again, has two different features and functionality. One is the reviewer that does actually your code reviews, but the profiler collects runtime performance data from your live applications and provides recommendations that can help you fine-tune your application's performances, basically. You can use that to help profile your applications in the cloud from a single centralized dashboard. Again, that dashboard is important because you're running so many of those pipelines through your systems. It currently supports JVM languages, and Python is what I know. And then what you really can do with it is troubleshoot latency, CPU utilization. Using Code Guru Profiler, you can reduce your infrastructure cost. It will give you recommendations on that. And then you can also, based on its recommendation, identify application performance issues, even your application's heap utilization over time are the metrics that it can provide to you. All right, back to DevOps Guru, which is, again, going to identify your operational issues or detect your operational issues. It is also based on machine learning capabilities, and it can highlight issues like misconfigured alarms in your system, resource exhaustion, code and configuration changes that could potentially lead to outages, right? So instead of me diving any more deeper into it, let's talk about how do you get started. So there's a way you can do that. You can get started with Amazon DevOps Guru by selecting coverage either from your AWS account, or if you know what CloudFormation stacks are, you can also select your coverage from those. DevOps Guru will start collecting historical application and infrastructure metrics to determine a baseline and alert you if it detects any anomalies down the line. And then in addition to that, you can connect this guy with an SNS topic to proactively communicate any insights to you, take any actions downstreams. Okay? And then one last concept about this quality assurance is chaos engineering. Chaos engineering? Anybody running it today? Yes, no? Not too many. All right, so continuous resilience would not be possible without talking about this, right? Why do you need chaos engineering? Again, it's a process of testing distributed computing system to ensure that it can withstand random and unpredictable behavior in the system, and that can happen at any point in time, as you guys all know. So what do you want to do? You want to stress your stress test your application by artificially creating these disruptive events. It could be server outages, it could be API throttling, it could be network traffic, name it. And then observe how the system responds, and then implement improvements. So we have a service actually called FIS, or Fault Injection Simulator, that will allow you to do this kind of chaos engineering experiment. It is a fully managed service. You don't have to worry about some of the infrastructure part of it. That's what it means. But you can use some of the pre-built templates that come with FIS to set up and run high-quality experiments and integrate FIS. Actually, you can integrate FIS into CI/CD. How cool is that? Like right after you deploy things into production and in your continuous deployment cycles, you could integrate that into your pipeline. And then more importantly, FIS gives organization a platform to perfect operational skills. We all want to keep improving on what we're doing today and make it even better. If you're churning features every 2 hours, you want to now start doing an hour every minute. Does anyone, again, I think I'm going to ask a question because I'm curious. How often do you release code into production? And I'm going to start by 1 month. Every month? Okay? Every week? Wow, that is impressive. Every day. Cool. And then every hour.
Every minute?
If I can just forget that. Every hour is not coming up here. So, gentlemen here. Every minute, thank you. Every minute? No? So prior to joining AWS, I was working for AT&T with their DevOps teams, and I was an architect helping them move some of their workloads to cloud. Learned a lot about DevOps over there. But I was in the media and entertainment part of the organization, and M&E, if anybody understands that, runs fast. You need to have buttons, colors changed, your phone's applications changed every day, every hour, because there's competition in the market to just make things better, nicer. Sometimes it's not even better and nicer, it's just, I need a different color, my God. And that's how fast it goes. So again, I'm kind of getting carried away here, but the goal is to get to a place where you're able to do something like that from best practices perspective. I'm going to hand it off to Ela, and I'll come back in a few minutes, but we're going to talk about two important topics that I think are governance and observability being very important.
So are you guys still there? I know it's a very, very big topic, but let's talk about governance. So who has done automated governance in their organization? See a hand there. Awesome. So automated governance is a very important aspect from a modern DevOps transformation standpoint. Things like having a consistent tooling, things about having GitOps tooling, adopting modern governance, having set of rules that can be followed across the organization is very important. So the first item I want to talk about in this topic is having one set of tooling. So when I talk about one set of tooling, the one set of tooling that I'm going to talk about here is using a single tool to deploy your cloud infrastructure into AWS. So obviously, AWS CloudFormation is a prime choice because we can use AWS CloudFormation to provision your infrastructure, crash your infrastructure, and obviously manage the state of your infrastructure. So from an operator persona standpoint, you can just use YAML-based snippet or a JSON-based snippet. You can just deploy code. That's it, boom. But what about your developer personas who knows Java, Python, TypeScript, whatever? So what are they going to do? So that is where there is something called AWS Cloud Development Kit, or there is some other thing called AWS SAM, which is serverless access model. So what happens in this scenario is that you write your code in your favorite language, but you synthesize the code into CloudFormation, and the CloudFormation gets deployed into stacks, and then you're going to manage and CloudFormation manages your infrastructure. So what this means for an organization standpoint, for a governance standpoint, is that you're going to use a single tool, which is CloudFormation, to deploy and manage your infrastructure. So that's going to be a very important best practice from a governance standpoint to keep the governance at scale. And then talking about deploying infrastructure. So how many of you use CI/CD pipelines to deploy your applications? I would expect everybody, right? Yes. So how many of you use CI/CD pipelines to deploy cloud infrastructure? Awesome. I see a lot of hands. Okay, so the important best practice here is you should also think about using CI/CD pipelines to deploy even your cloud infrastructure, which is basically, let's say your operator persona or your developer persona has written a CloudFormation or a CDK code. Think about having a GitHub, like a code commit repo or a code commit repo, checking their code there and having a pipeline, basically a code pipeline, which deploys to CloudFormation, which means that you are introducing infrastructure as a code and CI/CD best practices into your organization, even to deploy cloud infrastructure. So that's a very important best practice an organization should adopt from a governance standpoint.
If I can just add to what Ela is saying, we talked about creating those blue-green environments, identical environments. If you use IAC pipelines, you can actually deploy your green environment, run your test over there. If it all looks great, move the traffic. If it doesn't, use automation to destroy them if you don't need them, right? Rebuild your environments. Some of those things can be done through IAC.
Yeah, exactly. Okay, let's talk about GitOps stack. So we touched upon this during the organization adoption, but we're going to touch upon it again from a governance angle. So say you have a Git solution, which is basically code commit, or you want to use your existing non-AWS tooling like GitHub or Bitbucket, and then obviously talking about infrastructure as a code solution to deploy your cloud infrastructure, or using CI/CD solutions to deploy infrastructure as a code using CI/CD, a GitOps stack, all AWS native is definitely excellent, but we also support a lot of partner solutions, like talking about Terraform or Pulumi, or talking about Bitbucket for CI/CD solutions. So having a consistent GitOps stack with all the tooling that we have, having a consistent GitOps stack from a governance angle is very important for an organization, so that all of your ecosystem of developers can follow the same. So that's with respect to GitOps stack best practices. And I also want to talk about Cloud Development Kit. So I touched upon this talking about the governance model, but so little bit, sorry, just went a little faster. All right, so let's say you have your personas, developer personas with Python experience, TypeScript experience. What you can do is they can build a cloud development kit, use the cloud development kit to build their cloud infrastructure, and then you can synthesize the code to CloudFormation and then manage your infrastructure using CloudFormation. So this is something that we highly recommend from a cloud infrastructure development standpoint. All right, so let's talk about observability, the fifth one. Hang on, guys, so just the fifth one. So my favorite one, of course. So talking about observability, who does not want to monitor their application? So monitoring your application is very important aspect from an operational excellence pillar, from a well-architected framework standpoint. So what is observability? So observability basically has three different pillars. So logs, metrics, traces. So what are logs? Logs are basically time-stamped record of discrete events that's happening in your environment. Say you are connecting to a database, say you are calling a microservice, or say you are doing an external third-party call, logging it is basically one important pillar of observability. Then metrics, so time-stamped events that's happening, basically what is your CPU utilization, what is your memory utilization. Having those information is very important to take actionable insights of whether scaling it up, scaling it down, and so on and so forth. So metrics is a very important pillar of observability, and then of course the traces. So how your user journey is, how their flow is, what are the different calls they are making in a particular user journey or a call or a functional aspect, right? So traces is another important aspect. So summing it up, all these three together forms the three pillars of observability from an organization standpoint when you want to monitor the health of your applications. So AWS, from a native standpoint, support these observability tooling for infrastructure monitoring, for application monitoring, and synthetic monitoring. You folks should be obviously knowing about infrastructure monitoring and application monitoring, but let's talk about synthetic monitoring. What is synthetic monitoring? Synthetic monitoring is you want to know how real-time websites are performing, and basically you can take some actionable insights out of it. And that is what is synthetic monitoring. And we have a specialist tool in AWS called Synthetics, which is going to help you achieve or monitor those endpoints to see what is the performance there. Say you are using containers, say you are using serverless. For each of those genres, we have different tooling like Container Insights, Lambda Insights, to monitor your environment. So just to sum it up, right, this is the ecosystem of tools that we have from an AWS native standpoint to observe your environment. But let's say you use open source tooling, you are a great fan of Prometheus, a great fan of Grafana, and you use OpenTelemetry for instrumenting your application, right? So AWS still have mechanisms to do that, but we have it in a much better way, which means we have these as managed services. So from an Amazon managed Prometheus standpoint, the underlying infrastructure is going to be managed by AWS, and likewise for Grafana. So what you see in the right side is the ecosystem of tools that is open source native, but what you see in the left side is the ecosystem of tools that is AWS native. So depending upon your observability choice, the maturity of your organization, you can choose this tooling to observe your environment. And then let's talk about continuous observability. So we can use all those tooling that we saw in the previous slide, but you also need to use if you want to use ML insights to continuously monitor your environment, and maybe create some alarms random, or create some alarm automatically, or if you want to create if you want to detect critical issues without you doing any programmatical aspect about it, you can use Amazon DevOps Crew to achieve that. So that's why we highly recommend using Amazon DevOps Crew, and I know they will cover a lot of ground on Amazon DevOps Crew, so definitely something you guys can think about from a best practices standpoint. So that sums up the 5 different genres of best practices we talked about, starting from organization adoption, development lifecycle, quality assurance, automated governance, and finally observability. So with these, let's get to the climax. We saw a basic pipeline. With all these best practices that you have learned in this session, we're going to show a final pipeline which is adhering to all the best practices, which they will cover.
Thanks, Hila. So we're almost done, guys. Just one more slide, I promise. So just wanted to kind of sum it up, right? We're talking about architecture best practices as it relates to DevOps today. And a final architecture pipeline, just as I'm showing here. We've covered everything from, just as Ila said, what are the best practices when it comes to SDLC? Make sure you're breaking down your monolith into microservices. Make sure you're having your best practices associated with CI/CD, right? We talked about the dev and the test environments when you're building and kind of just committing code to the time that you're starting to release. But then we introduce DevSecOps as another concept, the fact that security must be inbuilt into your pipeline, that it is, not quite DevOps if you don't have security measures taken. So we talked about SAST, we talked about DST, we talked about how you could employ some other mechanisms to make sure that security is thoroughly tested, vulnerabilities are detected, and that you have notifications and mitigations associated with those threats. And then we moved into QA. Just as I said, it's not good if you can't really have your functional and even some of your non-functional testing incorporated. So security is part of that non-functional, but there's also load testing, there's performance testing. And make sure that as you're building your pipeline, you're thinking through these concepts and mechanisms that you need to employ within the pipeline. There are tools out there that you must leverage in order to do that. We talked about leveraging Code Guru and DevOps Guru, one for operational issues and kind of monitoring from an observability standpoint for your workloads that are already running in production, but one to actually just help you as you're developing and testing any changes or new products and services. And then we moved into the realm of governance, observability, making sure you're leveraging infrastructure as code. We talked about some deployment strategies. I'm going a little back and forth, but I'm trying to just say, hey, this is the entirety of what we can provide you, as we know, Ela and myself, and being here at AWS, that you must consider as you're building your DevOps pipelines. So with that, I thank you all for staying here. I'm really surprised that people aren't leaving the room. So I'll just say, if there is any questions, we're here. Please let us know. But also, it would be extremely helpful if you can put something for the survey that is associated with this particular session. It helps me and Ela kind of go back to our managers and our directors and say, hey, they really liked the session, or maybe they didn't, so we won't do it again.
All right. And also, you can reach out to us.
Thank you, guys. Thanks.
Thank you.